Okay, so previously we looked at the properties for, or the properties of negatives. Now, just to keep in mind, this video we will look at the same properties, but now we're gonna go through this expression. As you can think of, in math, we have this idea of a proof. So proofs are a way for us to be a little bit more expressive in how we're pulling on these ideas, right? So we'll see how somehow all these properties are connected to each other, but as I express them, I'm pulling on facts from each property. So let's start with number one, right? So um, sort of we do this a lot in math because we never take things for granted in math. We pull on previous axiom, previous ideas in order to enrich the ideas. So let's look at this a little bit closer. So let's say I have -1, right? So -1 is my element that exists inside of R. So this is the -1 is a multiplicative inverse, right? So that's the real context of what -1 is behaving with. So if I do -1 times A, and now this A is a positive A, this will be defined as a -A, which now will belong, or which we know exists now inside of this set R, right? So we know that A is in R. So we just show that if you take -1 and you multiply that with a positive R, you get a new element inside of this set R. So we see that -1 times A, we multiply them together. You can kind of talk about this new element that exists, which is the negative of A inside of R. Let's look at number 2 now. So if I have negative of -A, now here where it gets interesting. Now, previously we saw that -A is an equivalent expression to -1 times A. So let's use this fact that I can rewrite this as negative of -1 times A. Okay, now -1 of a times -1, this will now become a positive 1. Right, so this becomes 1 times A. So we know from the previous fact that you do the negative times, let's say times -1, this changes the value on the, right? So we think of this as a sign, right? So we're really changing the value of this. We're not changing the value of A, right? So -1 times -1, and to really what this is saying is that this minus is -1 also times -1. So these are two inverses together. This will create a positive 1, right? Now this positive 1 is what we're now going to multiply with A, which will now turn this into a positive A, right? So what is happening inside of this proof? So this proof is saying that, well, we already have the fact that -1 times A is creating a -A, but we can remove the -1 and we can negate that -1, which we have this definition that we can use. We'll now turn this into a positive 1. And then now we can take the positive 1 times A, and then this creates back A. So this gives us a way of getting back the original element, right? Let's look at number 3. So number 3 says negative a times b. Now let's do this similar expression that we've been working with, is that we can extract the negative 1, right? And then we do a, and then we'll say times b. Now, if you're noticing that I'm always extracting this negative 1, because that's where the sign is operating on, right? You're not operating on a, you're operating and changing the sign, right? So a times b will now give me ab. So now I have negative times ab. And then now this negative 1 times ab will give me a negative ab. So inside of this proof, so I'm going to start using this language of proving the behavior that's happening inside of this problem, is that if one of these is a negative, right? So let's say you have A and B, which are my elements. I'm always going to specify elements. If one of them is negative, if I take the product between them, it's going to change the behavior for both of them, right? So they're both going to be negative. So if one of them is negative and I multiply it with a non-negative, it's going to change the behavior of both. Okay, let's further on this way of proving these concepts. So let's look at number 4, which we kind of get for free. So number 4 is actually connected to number 3, but now we have the negative value on b. And remember, we're thinking this as an inverse, right? So first, we extract the negative 1. Good. We always extract first. And then now, I'm going to use the language of associative property to rearrange this. So I put negative 1 in the front, and then I say A times B. Typical way of contextualizing this problem is that we always extract the number, and then we place that in the front. And then now over here, I have A times B. So now this gives me negative times AB, right? So we think of AB as this new element, this product element. And then now we see from the previous fact, which we can use earlier, that this negative 1 times AB will give me negative A, right? So sometimes we say, well, why are we expressing it through this form? Well, we want to be very subtle in how we're deriving these. You can think of them as mathematical truths inside of how this wants to behave, right? So that's the reason why we're working through these steps. Okay, now let's say I have negative 1 times a plus b. Now I will rewrite this as negative 1 times ab. Good. Now I can distribute here. So this gives me a negative 1 times a plus negative 1 times b. And then now this negative 1 times a, which I use my previous fact, is minus a. And then this also from my previous fact will give me plus a negative b. And then now we learned earlier about this subtraction principal property. We can get the subtraction symbol through this, right? So I always want to specify that sometimes we confuse the minus and the subtraction sign, the minus and the negative sign as the same thing, but it's not. The negative sign expresses the inverse. The minus sign is an operation. So this is a great example to see how we can describe how we're expressing this. And this is the beauty of math. Okay, number 6, which is our final expression, is that we'll do negative of A minus B. And then now we recontextualize this as negative 1 times A minus B. Okay? And then now we distribute. So we'll say negative 1 times A. And then we'll say minus negative 1 times B. And then this further gives me this. And then this further gives me this. Right? And I always like to put my parentheses around this. And then now we looked at a previous property where this changes the sign back into addition, right? So we see how number 6 and number 5 are subtly connected here, where now I can change back into addition. So this is what we happen, like minus symbol and the negative symbol, when they kind of come together here, which is kind of be multiplied, it turns into this addition operation, right? So this is the very key point here that we're investigating this behavior. And then now we improve this as we can rewrite this in a new form as A minus B, which is the key. B minus A. Yes, B minus A.